Hello, welcome back to my YouTube channel. This is my second video. Now, I want to explain about electrical power system instrumentation tasks with my supporting lecturer, Mr. Irwan Herianto, STMT. Okay, the title is 150 kilovolt tower equipment and accessories for suspension type AA with two circuit line. Okay, I will introduce myself first. My name is Windy Astia Fahmiansyah. My attendance number is 19. I'm from class 3C. Table of content. 1. Introduction. 2. Fundamental concept of electrical transmission. 3. Types of tower transmission. 4. Transmission tower type based on function. And the last, tower equipment and accessories. Okay, the first, introduction. Introduction. Electrical transmission is the process by which large amount of electricity produced at power plants, such as industrial scale wind facilities, is transported over long distance for eventual use by consumer. Steel tower construction is a type of high voltage transmission line construction as UTT or extra high voltage transmission line SUTET that is most widely used in the LN network because it is easily assembled, especially for installation in mountains areas and away from highway. The price is relatively more cheap compared to the use underground channel and easy maintenance. A tower or electrical tower must be strong against the load acting on it, including 1. Tower weight and conductor wire compressive force. 2. Tensile force due to stretching of wire. 3. Wind force due to wind exposure on the wire or tower body. 2. Fundamental concept of electrical power transmission. Voltage, current, power, and electrical engine of the most frequently used term and the transmission line characteristic. 1. Voltage. The voltage of a transmission line determines the line's ability to transmit electricity. This electrical force or electrical potential is measured in volt V or more typically in kilovolt. 1 kilovolt same 100 volt. 2. Current. The current through a transmission line is a measure of the amount of electricity that is moving through a conductor. Current flow through a conductor is measured in amperes. 3. Power. Power flowing through a power station is measured in watts, or more typically megawatts. 3. Types of tower transmission. The transmission tower is an important accessory of the performance of the line depend very much on the design of the transmission tower. The electricity tower or pylon can be classified several ways. The most obvious and visible tower. 1. Lattice structure. 2. Tubular pole structure. Okay, the figure A is lattice tower or single circuit. The figure B, a tubular steel H-frame tower. The figure C, Gauge tower with double insulator string per fasa conductor. Figure D, lattice tower with double circuit, and the last figure is angle tower. 4. Transmission tower type based on function. According to the angle of deviation, There are four types of transmission tower. As per the force applied by the conductor on the cross arm, the transmission tower can be categorized in another way. 1. Tangan suspension tower, and is it generally a type tower? 2. Angle tower or tension tower, or sometimes it is called section tower. All B, C, and D types of transmission tower come under this category. Apart from above customized type of tower, the tower is designed to meet specially the major types of transmission tower can categories as below. 1. Suspension tower. The figure first is suspension tower. Mainly, the suspension tower are on the way of the straight line transmission. Is it? It may also vary maximum to degree of 5 angle. The high voltage suspension tower are designed to carry the only weight of the conductor in straight line position. Most of tower in any transmission line is fall into this type of tower category, and construction costs of suspension the transmission line are much cheaper compared to other of transmission line. This type of tower are used on line for straight line or for a small angle of deviation up to 2 degree or 5 degree. Conductor on suspension tower may be supported by means of E-string, phase string, or the combine of E and phase string. 2. Tension tower. Number 3, the figure 3 is transposition tower, and the last is spatial tower. 5. Tower equipment and accessory. Based on the function of each component, the SUTT or SUTET transmission system is classified as follow. 1. Current carrying. 2. Insulation of isolation. 3. Structure. 4. Junction of liaison. 1. Current carrying component included in the current carrying function are SUTT or SUTET components that function in the process of channeling electric current from the generator to the GE or GE or GTET, or from the GE or GTET to the others GE or GTET. Components that are included in the current carrying function, namely 1. Bare conductor. 2. Conductor motion suppression. Bare conductor. The conductor material used for electrical energy lines need to have the following properties. A. High conductivity. B. High mechanical tensile strength. C. Low specific gravity. D. Economical. And E. Flexible or not easily broken. The type of conductor based on the material. 1. Copper type conductor. B. C. Bare copper. This conductor is a good conductor because has high conductivity and good mechanical strength. 2. Aluminum type conductor. Conductor with aluminum material are lighter than copper type conductor. Their conductivity and mechanical strength are lower. This is the type of aluminum type conductor. Figure 1 is ACSR. Number 2 is TACSR. Number 3, ACCC. ACSR is aluminum conductor steel reinforced. TACSR is thermal aluminum conductor steel reinforced. And then ACCC, the conductor ACCC of type is timer composite as having high mechanical strength. Number 2, insulation. Insulation serves to isolate the part that is in tension with the non-voltage part. But during normal continuous operation and during the surge, including lightning, inside the transmission line, according to its function, a good insulator must meet the properties of 1. Electrical characteristic insulator has rated lightning impulse withstand voltage and working voltage minimum breakdown voltage according to working voltage and is an insulating material flanked by metal, so is it a capacitor? 2. Insulator must have mechanical strength to bear the tensile load of conductor as well as the heavy load of insulator and conductors. Okay, uh, pin insulator. Pin insulator is widely used for overhead high voltage power transmission line, and this type of insulation much popular in 33 kilovolt distribution line. Pin insulator are mainly classified into to according to their manufacture materials and suspension tower. Suspension insulator are the most commonly used insulator types in high voltage transmission application. Suspension insulator has higher economical effect for high voltage application compared to other insulator. Strain insulator. Strain insulator are widely used where the tension load of conductor is higher. The most important factor of strain insulator is a mechanical strength. Ground clearance around the conducting wire. Air insulation serves to isolate between the live and non-voltaic parts, and electrically and intercepting pasa. Failure of air insulation function is caused by breakdown voltage exceeded, improper distance, change of air resistance, overvoltage, and air clearance. Ground clearance has minimal clearance. 3. Structure. The structure is divided into three parts, namely 1. Bracing tower. The bracing tower serves from a tower structure that functions to maintain the lead wire at the curtain ground clearance distance so that the power transmission process continues. 2. Nuts and bolts tower. Tower nuts and bolts function to unite the bracing to form a tower construction. 3. Foundation. The foundation is a reinforced concrete construction to bind the tower foot with the earth. The tower foundation that bear tensile load is designed to be stronger or bigger than a suspension type tower. 4. Junction. Connecting the current carrying subsystem with the insulation subsystem. 1. Strain clamp. Strain clamp is device that is attached to the conductor to tension insulation equipment, which serve to hold the conductor on the tower tension. 2. Depth and compression. The component function is a conductor holder in the tower tension. 3. Socket clevis. These components serve to connect the ball insulator with the hot yoke on the tower tensor or suspension. 4. Bolt clevis. This component function to connect the insulator socket with a link. 5. Square plate. The components serve for the holder of or anchor conductor is the double conductor tower suspension and tower tension. Number 6, suckle to connect the link with the tower. Number 7, turnbuckle serve to regulate the tension or slack pull the conductor. And the last is link adjuster. This component serve to connect the yoke with the conductor and obtain the desired sagging. Linking the insulation subsystem or insulation with the subsystem structure. 1. Socket link bolt. The component function to connect the insulator socket with cold yoke on the tower tension. 2. Extension link to connect the traver with the yoke on the cold and side tension tower. 3. Shackle to connect the link with the tower. And the last, adjuster plate. The components serve to regulate sagging or andongan insulator on tower tension. Connecting the insulator and terminating the insulator to the junction of the conductor and the junction of the tower. Consisting of ceramic or non-ceramic ball and pin insulator. And then the last is connecting between the lightning safety subsystem, consisting of a DSV joint. Okay, this is the end of my presentation. Thank you and see you. Bye bye.